Good evening, everyone. My name is Mansi Tripathi. I am TA for the course Environmental Chemistry, and this is the problem solving session offered by NPGEL, and this is week 4. So, what we have gone through in this last week was basically about acid basis problem, and we have learned Visual Mintech. So this is a software that is very helpful in the identification of the species. Once you identify the species components, so it's very helpful to find out the pH as well as the concentration of various other species. So in this problem solving session, many questions will be based on Visual Mentec. Sir has very well explained how to use Visual Mentec. So please keep your calculators with you as well as a Visual Mentec software in the background so that you can solve questions with me like in your software as well as calculators. So please keep them ready with you. We'll start in a while. So let's see the very first question. So the first question is a monoprotic acid HA dissociates in water as below. So HA is dissociating as H plus as well as A negative. The pKa value is given as 3.29. The concentration of deprotonated form A negative. Okay, deprotonated form, why? Because proton, which is H, is removed from this acid, so it is deprotonated form, or we can call it as conjugate base. And AT means total concentration of A at equilibrium are 10 raised to power minus 4 molar and 10 raised to power minus 3.5 molar respectively. So what is the pH of the solution? For such kind of question, you need calculator because there will be log values, so you won't be able to do mental maths. So please keep the calculators ready, and we will use Ferris equations that is taught to solve this question. So please try to solve this question. I'll solve the question with you. So I'll first note down all the values. A negative is a 10 raised to power minus 48 molar, and the other thing, the A total is 10 raised to power minus 3.5 molar, and we note the peak A value. So we'll solve. Okay, so first you know that pH is equal to pKa plus log. Be very careful, we will use log here, not ln. Okay, why log? Because the definition of pH itself is negative log power, so we are talking about 10th log, not e. Okay, so that's why we will keep a here, and conjugate base upon or deprotonated form and acid. So this is activity, but we can take concentration also. Okay, then pK, what is given? 3.29 plus log, what is A plus? It is 10 raised to power A negative minus 4.8 divided by, uh, we are given 80. Okay, so 80 is equal to HA plus A negative, and what we need here is HA. So how can we calculate HA? Simply 80 minus A negative. So we'll keep it here directly. 10 raised to power minus 3.5 minus 10 raised to power minus 4.8. So just by solving this question, we can directly get the pH values. Okay. So please solve this thing and let me know what are you getting as the pH of the this particular solution. Okay, I hope you have solved the question. We'll see the solution now. The solution is 2.01, and this is how we have got it. We have solved everything, and the solution for this part is minus 1.277669, and when we subtracted it, we got approximately 2.01. So you have to be correct up to 2 decimal places in all the situations, because most of the questions will be given in this form only, this 2 significant places. Let's move towards next question. Second question is acetic acid dissociates in water as below. Okay, pKa we have the resulting pH, and the concentration of acetate ion at equilibrium is given. We have to find the total concentration of acetate. So this is same kind of question. Please try to solve this question, and you have seen the answer, of course. Then we will see if you get the same answer. So please try to solve this question. We'll see in a while. We'll see the solution now. It was very similar to the first question. Just be very sure if what is it is asking. It is asking about the acid concentration or the total concentration of acetate. Okay. So here also total concentration it's asking. So this is how we have the acetate value, we know the pH, and we know the pK. Just we have to put it in Henderson-Hasselbalch equation, and this is what we got. So HAC is 1.7378. So what is HAC? This is. Though then we are doing the component balance because we want total. The question is asking about total, not HAC. So total, just by adding this, we will end up here. Then by using the calculators, you can get these values. So by using a scientific calculator, there won't be any problem in getting these values. Okay. We'll move towards next question. Compute the pH of 5 into 10 raised to power, this is minus 8 power, molar HCl solution. Ignore the effect of ionic strength and assume that AI is equal to CI, means activity is equal to concentration. What does this mean? That this is a dilute solution. So you have to compute the pH of HCl, and we have to ignore the effect of ionic strength. Okay. So while doing this question, the first thing that comes to our mind, we'll see that it is okay, strong acid. So let's do it the conventional way by taking negative log of hydronium ion concentration. So in general, HCl is a strong acid. So when it dissociates, it will give H plus and Cl negative. What was the concentration of HCl? That was 5 into 10 raised to power minus 8. Since it is a strong acid, it will give us 5 into 10 raised to power minus 8 at same amount of C. Now when we are doing the negative log of H plus, we will get log 5 into 10 raised to power minus 8. What is the pH we are getting? I'll also solve with you. 5 into 10 raised to power minus 8 log 7.3. But we know acid always has pH less than 7, but here it is coming greater than 7. It means This is very wrong approach. Whatever the molar concentration of acid is, the pH will always be less than 7 because that is why it is acid, right? So when the molar concentration is very less, we need to take the dissociation of water as well. So apart from this equation, we need to take the dissociation of water as well. Both of these equations we will solve for H plus, then only we'll get the correct molar or the correct pH of such kind of questions, because the molar concentration is very less. So please try to solve this question. We'll see the solution. So I'll clear the screen for you so that you can get the solution. I'm Okay, so answer is 6.89, and this is the range, acceptable range by the computer. So 6.89 is the correct answer. So we'll see how we are getting this. So this will be solved in Visual Mintech, as well as you can solve it manually also, but Visual Mintech is an easier approach to do this such kind of question. So HCl is 5 into 10 raised to power minus 8 molar. This is the initial HCl. The knot is representing that. pK is less than 0, so it will dissociate completely. Means HCl is 0 at the equilibrium. So what is the species? H plus, Cl negative and OH. Okay, so that is why we are not taking HCl here, because it will be 0. So these are the components and these are the species. For preparing H plus, how much H you need? 1, and how many Cl? 0. For chlorine also 0 H plus and 1 Cl. For OH, this H plus in negative, we will get OH and it is 0. For HCl, how much you need? 1 H plus and 1 Cl. So what is the formation equation of H total? Is H plus minus OH, which can be equal to HCl. How it is coming? When we are talking about this, so H total is equal to H plus 1. We have to multiply these things for H plus. So H total is 1 into H plus 0 into Cl negative plus minus 1 into OH negative and plus HCl into 1. Okay, this will be in equal to. Okay, so we'll see this now. So this is the formation equation, that H plus OH negative, which is equal to HCl naught. And similarly, we can obtain the equation for chlorine atom. Therefore, Ht is equal to H plus minus OH. This is the formation equation that we are choosing. Now all you have to do is just replace OH by dissociation constant of water by H plus. So what is dissociation constant of water? It is just nothing but equilibrium constant of water, because this is liquid, so this will be equal to 1. So that is how we will get dissociation constant. So we will just replace the values and we can just solve this quadratic equation. We will get H plus, hence we can get the pH. What is pH? That is just negative logarithm of hydronium ion concentration. This is what we got as pH. This can also be solved in visual Mintek. This is the conventional approach because here only quadratic equation was there, so there was no problem of it in solving manually because you can get such approaches in your scientific calculator also. However, in various cases, the hydronium ion concentration degree can lead to 3 times or 4 times. So it's impossible, kind of impossible to solve manually. It will take so much of time. You have to solve various equations, various degrees. So it's better to solve this question in visual Mentek. So this is the next question. Cyanide ion is vital in metal plating industries because it can keep metal dissolved under condition where they would be otherwise solids and settle out in solution. So in metal plating industry, cyanide is added, but we have to maintain the pH greater than 10 raised to power 10.5 to stop the release of the toxic hydrogen cyanide gas. So the question is, so this is your pKa value, I guess. So if so the question is, we are preparing a solution by dissolving 10 raised to power minus 2 molar NaCN, sodium cyanide in water. So we have to say if the statement is true or false. And what is the statement? The pH of the solution that we will get after dissolving 10 raised to power minus 2 NaCN in water will be greater than or less than 10 raised to power minus 5. So based on that, we have to tell if it will minimize the effect of toxic hydrogen cyanide gas. So how this should be approached? So this is a reference diagram. First I'll write the equation that HCN gas, how it will go? H plus and Cn negative. So if this side is the concentration, this side is pH. So let's say this is 10 raised to power 5. This is our HCN and this is cyanide ion. So if somehow the pH becomes less than 10.5, the more part will be, major part will be cyanide ion, HCN gas, which is very toxic. So that's why we try to keep pH more than 10 raised to 10.5 so that whatever the concentration we get will be in the form of cyanide ion, which can be which can remain inside water. It won't be volatile, therefore it will not cause any harm to the body. So our major target is if the pH is coming greater than 10.5, then this solution is correct, then it will be true. Or if it is coming less than 10.5, then this much dissolution is not sufficient. So please try to solve this question. We will see the solution in a while.
Madam, your voice is not audible.
Okay, actually, I was giving some time to solve the question. Um, we'll see the solution now.
Okay,
So,
okay,
okay, okay, no problem. We'll see the solution now. So, NaCN, the total NaCN is given is 10 raised to power minus 2 molar. Okay. So, what I told, if the pH is coming more than 10.5, then most of the solution will be, the most of the cyanide will be in the form of Cn negative ions. So, there is no harm of the release of toxic hydrogen cyanide gas. So we want the solution to be this side. pH we want more than 10.5. So we'll see if it is coming by dissolving 10 raised to power minus 2 NaCN. So what is Na total? Nat total? It's Na and NaCN, which should be equal to NaCN naught. And how much cyanide total is, which is also equal to NaCN naught, because there is no another source of cyanide or as well as sodium ion. When we will put all these values in Visual Mintek, so here also Visual Mintek is important. So when we will feed all these values in Visual Mintek, we will directly get the result as pH 10, pH is equal to 10.547, which is greater than 10.5. Therefore, here it will, this is 10.547. So here cyanide ion is more as compared to HCN, hydrogen cyanide gas. Therefore, there won't be, there will be, the harm will be minimized. So it's not like there won't be any harm, because we see there is some gas also, but most of the part will be cyanide ion. So that is why this pH is enough. So answer is true. For solving these questions, please refer to Visual Mintek. Coming to next question. A solution is formed by mixing equal amount of H2SO4 and Na2SO4 in water. Initial concentration of H2SO4 is 10 raised to power minus 3 molar and Na2SO4 is 10 raised to power minus 4 molar. We will assume that both the compounds dissociate completely and can be neglected and equilibrium. We have to find the pH of the resulting solution. So when we will write H2SO4 equation, it will be something like this: 2H plus SO4, 2 negative. And how much H2SO4 is there? 10 raised to power minus 3. Then how much H plus we will get here? 10 raised to power 2 into 10 raised to power minus 3, and sulfate 10 raised to power minus 3. When we will solve for Na2SO4, since it is dissociating completely, this is what we will get: 2 Na plus SO4, 2 negative. This is 10 raised to power minus 4. This is how much we are getting: 2 into 10 raised to power minus 4, and this is 10 raised to power minus 4. Okay, so based on this thing, so how much sulfate total we have? 10 raised to power minus 3 plus 10 raised to power minus 4. Okay, how much sodium we have and how much H plus we have? This is concentration, which is equal to activity. Okay, so based on this, we need to find out H plus. So this can also be solved very easily in Visual Mintek. We just have to feed the values. I will show a screenshot of Visual Mintek also. So please try to solve this question. Sir has taught this thing very nicely in the class. So please try to solve this. We will see the solution now. And please match it with the solution. So what is H2SO4 total? 10 raised to power minus 3. How much Na2SO4 is there? 10 raised to power minus 4, as I have told. What are the species we are having? See, if in this question it would have not been written that it is dissociated completely, then two more things would have been added, H2SO4 and Na2SO4. But since the question is saying that it is completely dissociated, that's why these two things are not there. So what are the species we have? Sodium ion, sulfate ion, hydrogen ion and hydroxyl ion. And what are the various components that are enough to make all of these? Sodium, sulfate and hydrogen. So we will make the tableau. This is how we will prepare it. This was taught in week 2 also. Okay. So how much sodium we have now? 2 into 10 raised to power minus 4. As we some problem is there in the system. So how much sodium we saw here also? 2 into 10 raised to power minus 4. How much sulfate? 10 raised to power minus 3 plus 10 raised to power minus 4. Okay. So sulfate how much? 10 raised to power minus 3 plus 10 raised to power minus 4, which is equal to 1.1 into 10 raised to power minus 3. We can get this value from calculator. How much Ht is there? H plus minus OH, which is 2 into 10 raised to power minus 3. We will feed all these values in Visual Mintech. So we will put all these values in Visual Mintech. So this is given in millimolar concentration. Our one was in molar concentration, but this is given in millimolar concentration. So that is why H plus how much we are keeping? 2, sulfate 1.1 and sodium 0.2. And when we will solve this, we will get our result. How much H plus is coming? 1.86 into 10 raised to power minus 3. So what is the log activity? 2.756. If it is not visible, when I will upload this thing, then it will be very clearly visible, and when you will put this thing in Visual Mintech, you will see all the results very properly. So 2.756. So what is the pH of the solution? It's 2.756. Moving towards next question. This is kind of big question. Significant inhabitants of a city suddenly suffer from waterborne disease. Okay, in a place suddenly waterborne diseases started spreading. So this has happened in many places, like the first cholera outbreak in London was also because of sudden explosion of waterborne diseases. So as being an environmental engineer, you are advised to check various parameters of potable water supplied across the city. What are the parameters we are checking? Chemical and biological. After assessing the, when we checked the quality, we found out that there are bacteria, which are bad bacteria, present in water causing the outbreak in the city. Okay, and these bacteria are surviving in alkaline water, means when pH is greater than 7, these bacteria are thriving. But if the pH is less than 7, it is acidic pH, then these bacteria are dying. So our major aim was to reduce the pH to kill the bacteria, but we cannot drink very less pH water, right? We cannot drink water of the pH 2 and 3, right? So we need to maintain this pH to drinkable range. What is drinkable range? Drinkable range is 6.5 to 8.5. This is the water standard applied in India, which can be used by us as a drinking water resource. So first step was to reduce the pH to very less. Then we will add NaOH to make the water into this range so that we can consume it. So what happened? To control pH, 6 into 10 raised to power minus 4 HPr C2H5COOH is added. So it reduced the pH to 4.081. But this cannot be drunk, right? It is below 6.5. It cannot be drunk. So it destroyed the population of bacteria. But to neutralize, we also neutralized it by using 3 into 10 raised to power minus 4 molar NaOH so that it can come under drinkable range. But what we saw, that pH increased slightly. There was just little increase in pH. Maybe from 4.08 to 1 to it became 5.5, but still it is below the drinkable range. So we need to add more. 2 into 10 raised to power minus 4 NaPr is added to water so that the water comes under this pH range. So what is the final pH of water? The question is, what is the final pH of water? So around this range it is drinkable, but the question is asking what is the final pH of water from this. This is the various steps they have done. First, they added H plus in the form of HPr. Then they try to neutralize it by adding OH in the form of NaOH. Then they further tried to add OH in the form of NaPr. Okay, not OH, but like they have tried to add some base in the form of NaPr. So what is the final pH of water? This is 3-step question. It can also be solved easily in Visual Mentech once you find out all the species and the components present. Take 2 minutes and write down the equation. Then we will try to solve this question further. Okay, we'll see the solution now, step by step. So first, what was the first step? We were adding 6 into 10 raised to power of minus 4 molar HPr. Then we are adding 3 into 10 raised to power minus 4 molar NaOH. Then we are adding 2 into 10 raised to power minus 4 molar NaPr. So what is the total hydrogen concentration? It will be, first we are adding this, so HPr, then we are adding this minus NaOH, and here no H is there. H plus is not there. That's why in this equation we are not putting NaPr. So this is what we got, H plus. Then propionate, how much is there? HPr we are adding. Here no HPr is there. Here Pr is not there. So that's why we are not writing. Then NaPr we are adding. So this is propionate. Then what about sodium? Sodium, Here we have sodium and here we have sodium. So that's why we are adding both the things. Then we are writing this. Now just we have to put all these values in Visual Mintek. As you can see, H plus is 0.3 because it is millimolar concentration. Propionate is 0.8. And see, yeah, one important thing. Here all the things are in molar, but Visual Mintek, it is, sorry, this, my system is again stuck. Just a second. But here the concentration is in millimolar. So either we should change the setting of Visual Mintek to millimolar or convert this into millimolar. But here we are just putting the values as such because there won't be much difference because we are adding it in water. So we are taking something like 1000 kg of water is equal to 1 liter. So like we are taking density as 1 gram per meter cube, 1 gram per centimeter cube. So there is not much change. Okay. So that is why millimolar we are putting directly. And when we see when we will click here, species W. Oh, this is what we get. And we can see how much H plus we are getting. It's 5.104. So what is the pH? It is around 5.11. Okay, so this is still below the drinking water range. So we need to add some more alkalinity so that it can come to drinking water range. Okay, but the question was just asking how much, what is the pH? So we gave the pH, but still we need to add more alkalinity. Coming to next question, hydrofluoric acid is a weak acid. Okay, pK is 3.17. That is extensively used in industry because fluoride ion attaches firmly with iron, ferric ion as well as aluminum ion. As a result, it is excellent reagent for removing surface scales from objects made of iron or aluminum before they are painted. We have to compute the pH of the solution by prepared by adding 10 raised to power minus 3 molar HF. So we have the pKa value. We have the total concentration of the acid. We need to find out the total H, which will be what? H plus minus OH, which can be equal to HF naught. Okay, this will be the solution, but since pKa is given, we need to find out other approaches to solve this question. Okay, please try to solve this question. We'll see the solution in a while. We'll see the solution now. So the solution is the total pH will be 3.26. How we got this solution? We'll see. HF naught is 10 raised to power minus 3. HT is H plus plus HF. Okay, which can be equal to HF naught, which is 10 raised to power minus 3 molar. Ft is F negative plus HF. So this is what we can get from tableau. We know that HF is equal to, what is alpha naught? This is ionization fraction. So this is how we will solve this question. HF is equal to alpha naught into Ft. How we have solved alpha naught? This is diprotic acid, okay, right? So this is the alpha naught for diprotic acid. So by solving this equation, by putting HF, by replacing this thing in equation 1, we will get to this. After solving this equation, we will get H plus as 5.509 into 10 raised to power minus 4 molar. And what is the pH? pH will be negative log of H plus ion. So this is the pH we got. Okay, here in this question it is important to remember this part, how we are getting alpha naught. Please go through the lecture once again if you have any doubts in how we are calculating this alpha naught. First lecture of this week is enough to understand this. The next question is, a solution is made by adding 10 raised to power minus 3 molar HOCl and 10 raised to power minus 3 molar sodium propionate to water. When sodium propionate is dissolved, sodium ions are released and undergo no further reaction. Okay. Then NaOH is added until the solution pH is 7. How much NaOH should be added? Please try to solve this question. We will see the solution in a while. Then you can match a solution. We will see the solution now. The solution is, how much NaOH we should add is, it is 2.22 into 10 raised to power minus 4 molar. And how we are getting to this? HCl is 10 raised to power minus 3 molar. NaPr is 10 raised to power minus 4 molar. And what is the target pH? It is 7. So these are the species and these are the components. So these are the relevant reactions. And we have this equilibrium relationship from all these relevant reactions. Please look into it properly so that we can move towards next slide. Please note it down properly. Okay, moving forward, this is the mass balance equation. How much propionate we have? We have HPr plus Pr negative. How much OCl ion we have? HCl plus OCl. So we need to calculate the amount of sodium. Okay. Now we have this charge balance equation. Now here NaT is unknown. Its nice explanation is written here. Since we do not know the how much NaOH has to be added to adjust the pH to 7, therefore we have 3 equilibrium expression, 2 mass balance and 1 charge balance equation. Total we have 6 independent equation and there are 7 species, but one of them is H plus. So we have 6 independent equation and 6 unknowns because one is H plus, which is giving us pH is 7. So we can use these things and we can get to the required solution. How we are getting to the solution? So this is a charge balance equation. We are writing everything in a charge balance equation. This is the solution we are following. We are putting alpha 1 for HCl, HBr. This formula was explained earlier. Then substituting these values to the charge balance equation, we will easily get to sodium ion. Please have a look properly on this slide so that we can move forward. Okay, we'll see the next slide now. Okay, so here we concluded that 2.22 into 10 raised to power minus 4 molar NaOH will be added. You please go through these questions once again properly, and in case of any doubt you can ask me in the next session. The next question is, what is the pH of 100 ml of 10 raised to power minus 3 molar solution of sodium hypochlorite, to which 25 ml of 2 into 10 raised to power minus 3 molar HCl is added? So this is the dilution question. We just need to know how much HCl, hydronium ion, both of them are presenting. Then we can just multiply it, adjust to the volume, and we can get the pH. So please try to solve this question. We'll see the solution in a second. So the solution is 7.52. How this pH is coming? We'll see. Sodium hypochlorite is 10 raised to power minus 3 and HCl is 2 into 10 raised to power minus 4. Now we need to calculate the total of NaOCl, and this can be framed in the form of W also, in form of species and component, as we were doing earlier. So these all are, then we can just simply do dilution formula, that how much HT is there, NaCl into 100 plus HT in HCl into 25. Just multiplying and divided by the total volume, we can get HT. So this is the pH of this will give the pH of the solution. Now we will put all these values in Visual Mintek like this. Okay, all these values we will feed in Visual Mintek. and after that we will get the solution. So this is what we got, our H plus. Answer is 7.52. Coming to the last question. You have a flask in your laboratory on which label is smudged, means you don't know what is there inside the flask. So how much you can read? It is like a monoprotic acid. It is a monoprotic acid and the concentration is 2 into 10 raised to power minus 3 molar in a 0.055 molar NaCl solution. So Hx, the concentration is 2 into 10 raised to power minus 3 molar and NaCl is how much? 0.05 molar. And you measure the pH. How much pH you are measuring? It is coming 10 raised to power minus 3.09. pH is 3.09, so H plus is 10 raised to power minus 3.09. You need to determine the pKa value. So please solve this question. We will see the solution in a while. The solution is 3.25. How we are getting to it? pH is 3.09, so H plus is 10 raised to power minus 3.09 as I have told. We know the amount of HT, we know the amount of XT, okay, because this is monoprotic acid, so it is completely dissociating. NAT we know, CLT we know. Alpha naught is Hx upon X total, so this is how we will get HT. By combining these equations, we can get very well Hx, and hence alpha naught is this, and alpha naught we can write like this also. Okay, so this is from where we will calculate Ka. So that was all from my side for this session. I know it's little difficult to understand. Please go through the video. Please, I will upload the solutions. Please go through it once again properly. And in case of further doubts, you can ask me in the next session. So we'll close for now. Okay. So all the best. Bye
Okay,
bye.
thank you, madam. But
Yeah,
I have some doubt.
yeah,
So
sure.
the questions of 1 and 2 already you have explained.
Yeah. Yes,
So
I can explain that once again. That was very easy
question
question.
number 1 and 2, please
Yes,
kindly show the slides
yes,
once again, so I will be happy.
yes.
Question number 1 and 2, if you
Yes,
show the
I understood.
slides.
Yeah. Question number one was very simple.
Okay.
We have a
Yes,
monoprotic
yes, madam.
acid. We know the pKa
Yes, madam.
value. Just we need to find out pH of the solution. So just we have to use.
Yes, madam.
Huh. This is the solution for the question. We have to use Henderson-Hasselbalch equation. We know the pKa. We just need to find out pH. A negative we have,
Yes,
Ha we have.
yes,
Everything we have, just one equation.
madam. Yes, madam.
Yeah.
But second question, madam, kindly
Yes.
show the slides. So I will be,
Yes. It's similar
so I
kind of,
have a doubt.
huh, kind of similar question.
Yes, madam.
Hmm. Very similar.
Yes.
Shall I show you the solution?
Yes. So the solution.
Yeah. So this is the solution. We have everything. We just need to calculate the total ACT value. Here we have to be very careful that the question is asking about HAC or total ACT, because
Yes, yes.
some students will leave just
That is why I'm
till,
asking you, because same
huh,
type of question.
huh.
Madam,
Some
same
people,
questions are asking assignment. So that is why we are facing problem. That is why I'm
yes,
asking you.
yes, right. Some
Same
students will
questions are
leave in this step only. They will not read the correct question
uh,
properly and they won't reach here. They will just stop here. And system is checking, computer is checking, so it will
that
give
is why
0 marks.
that is why I'm,
Yeah. Yes.
yes, yeah, madam, yeah.
Please note down. Anyway, I'll share the
Kindly,
slides.
sir, madam, show the third questions.
Third question. Yeah.
Okay, sir. Madam, please kindly send. This is the third questions. Okay,
Yes.
the
This
answer
is,
this third question.
This question I think I have explained. Shall I explain again?
Already that I understood because the question because I understood,
Haha.
but how the process which process we are following to find out the answer, that is my doubt.
Here we are also using
So,
visual
madam,
Mintek. Huh.
so visual maintain is it allowed to for the examination during the examination? Is the
No,
software?
no. For examination, na, most of the question will be from this chapter. Will be from like question number 1 and question number 2. Okay.
Okay, okay.
Huh. But other these things will be
Because if the
uh,
question is like
like
this way, madam, if the question is like asked like this way in the examination, so it is very difficult for us to do this answer to find out the answer
yes,
because the
that
Ventec
is there.
software, it is very essential to find out the answer.
Yes, right. But if the question is like question number 3, here you have to just solve this
Yes,
equation. So here it won't be that difficult.
yes,
But
yes,
yeah, if it is coming third power, fourth power, then it will be very, very difficult. So, but I
yes,
don't
yes.
think also such kind of question will come.
Okay, 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 madam.
Okay.
Thank you, madam.
Okay. Thank you so much.
Okay, thank you very much.
Thank you.